Hey guys, so I'm sorry that I can't be there today, but at least you get my beautiful voice helping you out. So, the first thing is going to be that all right angles are congruent. So if angle 1 and angle 2 are right, then angle 1 is congruent to angle 2. And the reason for that is all right angles are congruent. And that makes sense because remember, congruent angles mean they have the same measure, right? So if all right angles are 90 degrees, that means that all right angles have the same measure. So that means that all of them are congruent. All right. Here we go. So remember, every single proof starts with given. This time we have two different givens. So I'm going to start with AB is congruent to BC. And that is given to me. And then I am also given that BC is congruent to CD. Now here at the end, I'm trying to prove that x equals 4. So that's what's going to go down there at the bottom. So now let's first look at our given and see what we know. So we know that AB, so I'll put a little tick mark on AB, is congruent to BC. So I'll have a little tick mark on BC. And then I know BC is also congruent to CD, so I'll put a little tick mark on him. What you might notice is that now I know each one of those segments is going to be congruent. So then I'll know that AB will also be congruent to CD. AB is congruent to CD. And if you take a look, that middle guy just kind of went away. Like I drew up here, that BC just kind of went away. So when those guys kind of run into each other and that guy goes away, that's going to be the transitive property. If you tell me substitution there, I would understand, but the way that it kind of lends itself to transitive property just a little bit more. Now, over here, if you see x is equal to 4, right? So what we want to be able to do is we want to be able to say that, or turn this into an equation instead of just having things be congruent. So if I know that AB is congruent to CD, then I know AB is equal to CD. And remember, whenever I go from congruent to equal or from equal to congruent, how do I know that two things that are congruent are equal? Definition of congruence. Now let's take a look at our diagram. So if we look up at our diagram, I'm going to have that AB is equal to, well, in the picture, AB is equal to 3x minus 1. And since that's just written in the diagram, that's actually a given. You don't have to write diagram next to it. I'm just trying to help you out so that way you know what's going on. Now, if AB is equal to 3x minus 1, then that means CD is going to be equal to 2x plus 3. And that is also given to me. So now I can set up my equation. I know that AB is equal to 3x minus 1, so I'll put in 3x minus 1 for AB. CD is equal to 2x plus 3, so I'll put in 2x plus 3 for CD. So I'm going to end up with 3x minus 1 equals 2x plus 3. So on both of those, since I put in something for something else, That's called substitution. And then we'll solve these equations like we did earlier. So the first thing I would want to do is go ahead and subtract my 2x over. So 3x minus 2x is 1x. Minus 1 equals 3. So since I had to subtract the same thing on both sides, that's going to be the subtraction property of equality. And then my last step to solving is going to be adding 1. So x will equal 4. And since I got that by adding, that's the addition property of equality. And then we'll double check that's exactly what I wanted to prove. X equals 4. Yep, that's what I wanted. So that proof is good to go. He's a little beefy, but at least out of the 9 steps, 4 were givens. So almost half of that was just given stuff. So even though it looks terrible, it's not that bad? I don't know. I'll take it though. Okay, over here. Every single proof starts with given. Angle A and angle B are complementary. Now hopefully that little extra sheet there is going to be helpful to you if you forgot what complementary means. But complementary means that they're going to add up to equal 90. So I'm going to add them together, angle A and angle B, and set it equal to 90. And I found that out because of what complementary meant. So that's going to be definition of complementary. Now that we have an equation, it might be helpful to be able to take what I have in that diagram. So I know that angle A is going to be equal to 6x. And that was given to me in the diagram. And then I found out that angle B is equal to 4x. And that was given to me in the diagram. So now I'm going to go ahead and put together all my pieces. So in for angle A is going to go 6x. And in for angle B is going to go 4x. So I got 6x plus 4x equals 90. And since I put in something for something else, that's called substitution. And then we'll start to solve. So I have a 6x and a 4x make 10x equals 90. I got that by combining like terms, so CLT. You could also tell me simplify. I'd be fine with either one of those. And then if I wanted to solve, I'm going to divide by 10 on both sides and get 9. So since I had to divide on both sides, that's going to be the division property of equality. And we're just going to double check, is x equals 9 what I wanted to prove? Yes, it is, so I'm happy. Yay. Okay, so next one. Every single proof starts with given. So I got angle A, B, C, and angle B, C, D are right. And that is given. So now what we'll do is we'll think back to, we learned something about right angles today. And we learned that all right angles are congruent. So that means that angle ABC is congruent to angle BCD. And that's just going to be all right angles are congruent. And then I want to get an equation, but equations only happen when there's something to be equal. So if I know ABC is congruent to BCD, then I know that ABC is equal to angle BCD. That M out in front is just measure of angle. Don't worry about it too much. You can put it there or not put it there. I'm not too terribly concerned. But how do I know that two angles that are congruent are equal? Well, they're congruent. So that's definition of congruent. And then I need to see what I can actually put in there. So I know that angle ABC, if I look at the diagram, is going to be equal to 2x plus 40. And then my other angle, angle BCD, is equal to 4x minus 10. And I got both of those from in the diagram. So I'm just going to put little g's for given. All right, so then I'm going to take what ABC is equal to at 2x plus 40, and I'll put it in for angle ABC. And then I'll take what BCD is equal to and plug that in for BCD. So then I'll end up with 2x plus 40 equals 4x minus 10. So since I put in something for something else, that's substitution. All right, then I would start to solve. Now, I'm going to solve it the way that I would always solve it, and so please don't think that anything is going to go on weird. I'm just solving it a different way than how they assumed I would solve it. So the first thing I would do is subtract 2x from both sides. So I end up with 40 equals 2x minus 10. And since I subtracted 2x from both sides, that's going to be the subtraction property of equality. Then in my next step, I would go ahead and add 10 on both sides, so then I would get 50 equals 2x. And I got that by adding 10 on both sides, so that's the addition property of equality. And then to solve for x, I would divide by 2 on both sides. So remember, I can't just switch whenever I feel like it. If I divide by 2 on both sides, I end up with 25 equals x. And I got that by dividing. So that's the division property of equality. But that's not exactly what we want to prove. We want to prove that x equals 25. So that's still another step in my proof. That's not exactly what I want. So to be able to say that x equals 25, I switch the side of the equal sign. That's the symmetric property. And since that is exactly what I want to prove, I am good. All done. All right, here we go. So every single proof starts with given. P bisects AB. And that was given to me. So I'm just going to put a G for given. Now, if you look at your definition sheet, what does it mean to bisect? It's going to cut so that each side is congruent. So I'm going to know that AM is congruent to MB. And I knew that because of the word bisect. So my reason is going to be definition of bisect. Now remember, I want an equation, so I need to have an equal sign in there. So if I know that two things are congruent, then I also know that they are equal. So AM equals MB. So how do I know that two things that are congruent are equal? Well, that's what it means to be congruent. So that's going to be definition of congruence. Now I'd like to be able to shove some stuff into that equation. So I'll get some numbers associated. So I have AM equals 2x plus 5. And that was given to me in my diagram. And then it tells me that MB is equal to 10 minus 3x. And that was given to me in the diagram. So I'll take what AM is equal to and put it in for AM, and I will take what MB is equal to and put it in for MB. So then I end up with 2x plus 5 equals 10 minus 3x. So when I put in something for something else, that's called substitution. And then we'll just go ahead and start to solve. So I like to keep all of my x's positive. You don't have to. As long as you are doing something mathematically valid, you should be fine. But I'm going to go ahead and add 3x. So 2x plus 3x is 5x. Plus 5 equals 10. And I got that by adding. So I'm going to have addition property of equality. Then the next thing I need to do is subtract that 5 over. So that's when I end up with 5x equals 5. Because I subtracted on both sides, that's going to be the subtraction property of equality. And then the last thing I would do to solve for x is divide by 5. So then x equals 1. And since I got that by dividing, I need the division property of equality. And then I'm going to double check that what I proved was what I wanted to prove. So I proved that x equals 1, and I wanted to prove that x equals 1. Cool. All right, so here's what I want you to do. Go ahead and flip to the next page and get started on your homework. Do your best, okay? Remember, I don't want there to be any crying over math. It will all be okay. We'll go over questions on it on Friday. Okay? I hope you have a wonderful day. I will see you later.